Welcome to Unit 5, Lesson 8, Unknown Exponents. Let's find unknown exponents. What happens when we don't know the exponents? Okay, solve each equation. Be prepared to explain your reasoning. So this one is simple. All you got to do is cross multiply. So when x over 3 equals 12, you just multiply both sides by 3. Get rid of the denominator. X equals 36. Okay, that's that one. For the next one, 3x squared equals 12. You're going to divide both sides by 3. X squared equals 4. Take the square root of both sides. X equals plus and minus 2. Do not forget the square root of the even roots of positive numbers. Even roots of positive numbers give you two roots, one positive, one negative. All right, now, on this index right here is no number written. Mathematicians are lazy. They don't like writing square root because they want you to understand that square root, any radical with no index is the square root. The number 2 goes there. Okay, this is going to be the last one we do on this page. Okay, x cubed equals 12. To get rid of a cube, you take the cube root. So now you have to write the cube on the index. And x equals the cube root of 12. This is an exact number. We're going to leave it like this, or you could write it 12 to the 1/3. Okay, now looking at the next three. The cube root of x. To get rid of a cube root, you have to cube everything. Cube, what do I write? Square cube. So x equals 12 cubed. And 12 cubed is, let's see, 12 to the 3rd power. 1728. Okay. Now, 3x equals 12. The 3 is under the radical symbol, so this means you square root both sides. To get rid of a square root, you square both sides. 3x equals 144. Then you divide by 3 on both sides, and x will equal 48. Okay, now, 3 over x equals 12. To get rid of anything in the bottom, you multiply. And yes, you can multiply by x on both sides. 12x, then we divide by 12. And 3 over 12. Reduce your fractions. 3 goes into 3 and 12. 3 goes into 3 once. We're going to divide by 3 over 3. Oh, I shouldn't have put that out front. It's supposed to go on the back because division has to go in a certain order. And 3 divides into 12 4 times. There you go. Okay, so now let's look at what's going on here. Here's a pattern of a trapezoid decomposed into similar trapezoids at each step. All right, so let's not worry about the question. Let's see what's going on. So to go from step 0 to step 1, we have 1, 2, 3, 4 trapezoids. So we're at 1, then we're at 4, and then here, each one is in 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So that's 16. So what we're doing is multiplying by 4 each time. That's our rate of change, times 4. Because 4 to the 1st power is 4. 4 squared is 16. If n is the step number, how many of the smallest trapezoids are there when n is 4? So our start is 1. So y equals, I'm going to hit the button. 1 is our start. Our change is 4. And we're going to put to the x power. We can't put n into the calculator. And then hit second graph. And then just scroll down when x is 4 and when x is 7. And what do we get? So when x equals 4, y equals 256. So in step 4, there are 256 trapezoids. When x equals 7, look at this growth. X equals 7, y equals 16,384 trapezoids. Okay, at a certain step K, there are 262,144 trapezoids. So now, K is our step, which is our exponent. If we have y equals 1 times 4 to the k power, when does that equal 262, 144? Okay, you just keep scrolling down, and k will be 9. So how will we do that? There's lots of ways to do it, but the easiest way is to write the equation like we've been telling you to do in all the lessons, and then hit second graph and scroll down a table of values. Okay, let's look at this one. Problem, successive splitting. In a lab, a colony of 100,000 bacteria is placed on a petri dish. The population grows exponentially, tripling each hour. So first thing we want to do is write our equation. That's the first place we start. So 100,000, I'm going to write 100, understanding that it's in thousands. So it triples, that's our rate, every hour. So x equals 1 hour. So how would you estimate? So what we would do is 100 times 3. If x is 1 hour and 4 hours, 4 times x, which is 4 times 1, which is just 4. Now, 90 minutes is 1.5 hours. So for 90 minutes, we would do 100 times 3 to the 1.5. Because you're just taking these times and multiplying it by x. And to the 1/2 hour is 100 times 3. Half an hour is just half. And then if you want the exact number, you can always put this into the calculator. But remember, these are in thousands, so add 3 zeros at the end of your numbers. How would you estimate or find the number of hours it would take the population to grow to 1,000 bacteria, double the initial population? So it doubles in 1 hour. So that's what, no, double, not, oh, I'm sorry, triple. It triples every 1 hour, not doubles. It triples every 1 hour. So let's see, if we divide an hour into 3 parts, 60 minutes divided by 3 is 20 minutes. Double would be about 40 minutes. So it would be 100 times 3 to the 2/3. Not triples, but doubles. Okay. How much to get 1,000 bacteria? From 100,000, how much does it count to go up? Okay, this is worded kind of funny. So what they did was they took 100 times 3 to the x, where x stands for 1 hour. And then what they want us to do is ignore the 1,000 part and just get to 1,000. So this 1,000 is times 1,000. So it's really 1,000,000 bacteria. But, well, 1,000 times 100,000 is 3 zeros on 100,000, which is 100 million. I'm sorry. It's 100 million. Ignore the 1,000 part, and then ignore the 100,000 part in the original answer. So put this in the calculator, go to your table of values, and see when 100 goes to 1,000. So after 1, when x is 1, y is 300. When x is 2, if we're tripling, y should be 900. When x is 3, y is going to be 2,700. 1,000. 1,000 is close to 2, so it's going to be, x is going to be really close to 2, slightly greater than 2. And then next week we'll learn how to exactly find the time. Okay, so this is the most important thing out of today's lesson, because because everything now we're going to do from now on is going to be in the calculator. Remember, we're counting exponents here. The x stands for the exponent. So you have to know your 2's. 2 times 2 to the 0 power is 1. 2 squared when x is 2. These are our exponents. This is y is 2 to what power? So 2 squared. I'm sorry, wait, I'm off. I am off here. 2 to the 0 power is 1. 2 to the first is 2. 2 squared is 4. 2 cubed is 8. 2 to the fourth is 16. 32, 64, 128, 256, 512, and then 1024. These are numbers that we should memorize because the 2 chart is very popular in science class. Now you'll get it in high-level chemistry for all you high-level chemistry persons out there. All you would-be nurses that want to get a real college degree in nursing. So 2 to the 0 is 1. 2 to the 1/2 is the square root of 2. 2 to the 1 is 2. 2 squared is 4. 2 to the fourth is 16. 2 to the fifth is 32. 256 is 8. And then 10 is 1024. And then conversely, to flip them over, this is -2 and -5. Because we remember that negative exponents flip the fraction upside down. And that's how we get those. Now, 5s. You don't have to not waste your time. You don't have to expend the extra brain energy to memorize your 5 exponents. But it will be helpful for you math and science majors. Mathematicians are lazy, so for the half one, we don't write the 2 here for the square root. It's understood to be square root. 1, 3, 4, 5, 0, -1, -2.